7th grade math, test 22, problem number 1. Well, number 1, they give us the rate for 12 markers as 1440. So what we do is we take that 1440 for 12, remember money on top, right? And we just divide to get the unit rate, or how much per one. So we divide in and out, we get 1.2, it means it's $1.20 per marker. Problem 2, they give us two tables and they ask us which ones are proportional. So if I look at the first table and I take the coordinates from those, I take x is 1/5 and y is 5. And since we're used to putting y on top for constant of variation or slope, I'm going to go ahead and do the same thing. I'll put y on top and x on bottom. On top, over means divide. Dividing by a fraction means multiplying by reciprocal. Okay, so that constant of proportionality is 25. So what I do is I take the next point here, I test all of them, and I put 10 over 2/5. 10 over 2/5 means 10 divided by 2/5. 10 divided by 2/5 means 10 times 5 over 2. We flip it upside down, right? That's how we divide by a fraction. Do my factor trees, cross out my ones, and again I get a ratio of 25. So then if I do the same thing with that last point right here, I put y over x again, I get 15 over 3/5, means 15 divided by 3/5, which means 15 times 5 over 3, multiplied by reciprocal, right? Keep change, flip. Alright, and then we do our factor trees, cross out our ones, we get the same thing. If we get the same thing every time, that is a proportional relationship. So table number 1 is proportional. Let's look at table number 2. Table number 2, we have another table, and then we just do the same thing. We put y over x every time. Fortunately, we don't have fractions this time. So if I just put 6 over 2, I get a ratio of 3. I test the next one, 12 over 4, ratio of 3. And the last one, 18 over 6. Whoops, that's a typo there. Got to talk to my secretary about that. That's a typo there. 18 over 6, we get a ratio of 3. They're all the same. That means tables 1 and 2 are both proportional. Alright, so moving on to number 3. Number 3, we have which expressions are equivalent to this expression here. So we always have to simplify first, right? That means distribute and combine like terms. But there's nothing to distribute here, so I just combine like terms. I go right here, I add my x's with the x's. I have 4 positives, 5 positives, 2 negatives. I'll use teams for that. Over here, add my constants, 7 positives, 9 negatives. We know when we're using teams, we combine our teams. Opposite teams mean subtract. Who has more? And that's how we get our sign. So that's how we simplify the original expression. So I look at expression number 1, and to compare it, expression number 1 is already simplified for me, and that's not the same. So don't pick that one. Expression number 2, it is the same. Plus negative 2 is the same as minus 2. So expression 2 is part of my answer. Expression 3, if I were to combine these two, I get 7x plus 16. That is not the same. Don't pick that. Expression 4, I get 7x minus 2. So the answers are 2 and 4. Number 4, we have an expression that we have to use a Pythagorean theorem. Excuse me, wrong class. We have to use the distributive property. There we go. To simplify this. So I can do the rule for subtraction first, right? Draw 2 sticks. Distribute. 4 times 2.25. You should get 9. Go out to the side. Make sure you're doing that right. And then 4 times negative 4 and 25 hundredths b is negative 17b. Now, if I take these two and switch them around, I get negative 17b plus 9. That's called descending order, right? Put the one with the letters first and the constant second. Then I look at my expressions. I see that expression 1 is the same, expression 2 is not. It has the wrong signs, and expression 3 is not. So the answer that time is only expression 1. Problem number 5. We have an inequality that we have to describe the solution to, which means we have to solve it first. So I look at these two here. I do the rule for subtraction, and then I work farthest away from the variable. To isolate this variable, I do the inverse operation. I add 3 to both sides. Then I divide by negative 7. Remember, if you have a negative coefficient, when you divide, the number that you divide by also has to be negative on both sides. When you divide by negative, that's when we reverse the inequality. Now, if I were to say the letter first, d is less than means my answers are all the numbers smaller than this, and since the line's underneath, equal to. Well, that means that's going to be a closed dot, arrow to the left. Now, sometimes the variable's on the right side. So, this answer, this solution is the same as this solution here too. And even though this reads negative 2 is greater than or equal to d, if I were to say the letter first, d is less than or equal to negative 2, that would be still closed dot, arrow to the left. Okay, so if the arrow's away from the letter, it's going to be arrow to the left. All right, we're taking a look at problem number 6 now. Sam is shopping at a bicycle shop. He has $200. So this is all the money he has on one side. And put all the money he spends on the other side. And the money he spends is this. He's got $130 picked out for a helmet, $15 per guide. How many guides can he buy? What's the maximum number? Well, I want you to think about this, because sometimes the amount goes towards the total. Sometimes it goes towards the expression side. And this time, if this is the total, this isn't how much he's spending, this is his total that he has, this can't exceed how much he spends. So that's why the arrow goes this way. So when we solve this, we work farthest away from the variable, like we said earlier, divide everything by 15, and we get 4. Here's the work down there if you have any issues with the division. We get 4.6 repeating. Now, my answers are everything less than or the same as this. Well, you can't buy 0.6 guides. You can't buy 6/10 of a guide, right? So the answer is it 4 or is it 6? Well, it has to be less than. That's why we use that decision. This is a situation where we would always round down. Sometimes we always round up. So the most you can get is 4 guides. Next one, 7. Lucas has 60 minutes of video game every Saturday. If he has already played 15 minutes, what percentage does he have left? Well, if I subtract those two, I see he has 45 minutes left. And this is asking 45 is what percent of 60, so we use percent proportion. Cross multiply. 45 times 100 just means add 2 zeros to 45, divide by 60. We go in and out. Now remember, when you're dividing and you have zeros on them, you can cross those out, right? Make it easier for yourself. Don't have to, just makes it easier. And then I get 75, which means 75% because it's percent over 100 for percent proportion. Number 8, we have a proportional relationship. All proportional relationships have the same equation. Y equals slope x, or y equals constant of proportionality x, right? So the way we get that number that goes in front of x is we just take a point. We put y over x, right? That's the rate of change. Okay, but since they said commission, we'll use C for y this time. And they tell us because it says the y-axis is labeled commission. And whatever's on the x-axis is going to go where the x goes. And it says number of sales, so we use S instead of X. So all I got to do is take one point, put Y over X, and put that number right here, and that's my equation. Number 9, Morgan bought some gloves, $15.50 each, $15.50, with a 6% sales tax. So what we can do is we can find 6% of $15.50, and like we said before, okay, we put percent over 100, it goes is over of. So I cross multiply. 1550 times 6 is 93. How do we divide by 100? We move the decimal 2 times to the left. So 6% of $15.50 is 93 cents. Now I got to add that back on to 1550 because you're not just paying tax, you're paying 1550 plus the tax. Okay? Now another option is just to find 106% of that and you'd be done. You wouldn't have to do this last step. So whatever you prefer, go ahead and do it that way. Now we have to find how much it is for 6% sales tax on $20 gloves. So we're going to find 6% of 20 again. Same thing, cross multiply, divide by 100, move the decimal 2 times, add $1.20 onto 20, and we get $21.20. And the question was, how much do they pay together? So I just add these two. Remember to line up your decimals when you're adding or subtracting decimals. So for 10, strength coach gets 165 for 3 sessions. Well, if we find the unit rate, remember it's always money on top, right? So we go 165 divided by 3. I divide those and I see it's $55 a session. That's how you get the unit rate. How much per each one, how much per one, you divide them. So if it's $55 per session, he's getting a 10% raise. I can find 10% of 55, again, using percent proportion. Cross multiply, divide, and we get that his raise is going to add $15.50 for every session, so we add that on to his old amount, and we know that he's now getting $60.50 per session. For 11, it says that Ed has this much flour, 19 3/4 cups, and he used 5 1/4 cups to bake a cake. How much flour is left? So this is a subtraction problem. Now normally, I teach you to do subtracting mixed numbers the same way we multiply and divide mixed numbers. That means convert everything to a fraction, get a common denominator, but in that case you have to get lowest common denominator, and then you can convert if necessary. But there's a shortcut for this one, and the reason we know there's a shortcut is because, look, we already have the common denominators, plus, you see this numerator? It's bigger than this. So there's no need to borrow and do all that nonsense. So, since it's simply set up for us like that, we're just going to subtract. 19 take away 5 is 14. 3 take away 1 is 2. Keep the common denominator, but don't forget to simplify your fraction. Number 12, which expressions are equivalent to this one given? All right, well, we got to simplify this one. Again, we always have to distribute first, but there's no numbers right in front of the parentheses, so we don't have to distribute. So we just combine like terms. So I take a look at this. 6x's plus 1 more x is 7x, plus 7 more x's is 14x's, and there's only 1 3. So when I simplify that, this is the same as 14x plus 3. Expression 1, 14x plus 3. Well, of course that's the same. Expression 2. Expression 2 says 10x plus 4x plus 3. Well, if I combine those two, I get 14x plus 3, so that's the same too. Expressions 1 or 2 are part of our answer so far. Expression 3. If I simplify that, I only add my x's, right? Don't add the 3 to those because it doesn't have an x. So 6x and 5x is 11x plus 3. That's not the same. And expression 4, 13x plus 3. No, that's not the same. So expressions 1 and 2 are the answer. Now for problem 13, they say to us, find the scale factor. Well, we have to figure out what's the old one and what's the new one, and that's important. So they say, the directions say, figure A produces figure B. So figure A is the first one, figure B is the second one. And the reason that matters is because the way you find scale factors, you put new over old. So we take two corresponding sides, right? It doesn't matter which two. I'll take the two on the left. So for the little one, that distance is 9. The corresponding side to that little one is, for the big one, for figure B, is 3. Figure A, we have that side 3. Figure B, that corresponding or in the same place side is 9. So if I put new over old, I get the scale factor, that's 3. Now, if it said from B to A, that would be getting smaller, so I'd switch it and I'd put new over old and I should get a fraction. If it's shrinking, it should be a fraction. If it's expanding, it should be a whole larger than 1. Okay? All right, so 14, we have a scale drawing, 3.5 inches high, and they say 1 inch, the scale is 1 inch to 1.2 feet. So what I do is I take 3.5 inches times 1.2. I multiply those two, and that's it. 15, they give us the circumference of a circle, and they tell us to find the radius. Well, the circumference of a circle is 2 pi r. It's also pi d, but since they're asking for radius, I'll use the formula that involves radius. So I put the circumference where the c goes. I have 2. I always use 2. That's part of the formula. And I know pi can always be rounded to about 3.14. Now I have an equation I can solve. In other words, I can figure out the number for the letter. In other words, I can figure out what the radius has to be. So we always want to multiply first. That's a good idea. Multiply those two first. And it's not a bad idea to memorize it. 2 pi is 6.28, right? Just double the 3, the 1, and the 4. It's 6.28. So now we divide, and the mistake here that people make is they try to divide this by 3.14 instead of 6.28. And we're now using calculators. So I push this in my calculator first. Then I hit the divide button. Then I type this in. And I get this really long decimal, but the directions tell us we're going to round to the nearest whole number, so that's about 27. And to be exact, we should have said about 27 centimeters. So 16, they give us a circle with a diameter of 50 feet. That means the radius is 25 feet, right? It's half of that. So if I'm going to find the area for that, the area is pi r squared. Not to be confused with 2 pi r. These are different, right? 2 pi is not the same as r squared. So I plug it in. Pi is 3.14. My radius is 25. I have to go 25 times 25 first. Do not multiply these two first. Do your exponents first. Order of operations. 25 times 25 is 625 times 3.14. Again, we're using calculators. We got the area of the first circle. Second circle, they give us diameter, so I convert that to radius, which is half of it. And again, I'm going pi r squared. I do 50 times 50 first in my calculator, then times 3.14. Then what I do with these two, if they want to know the difference, I just subtract them. That's the difference between those two. So for 17, again, we start out with circumference of a circle. But they say, you know, we're only going to shade a certain part of the circle, so what's the area of that part? So let's find the area of the whole thing first. So again, we know that 2 pi is 6.28, so I divide that with my calculator, punch this in first in your calculator, punch that second, pause the video, make sure you're doing that, and you get the same thing I got here. Now, if you get a long decimal like this, what I put in the directions to give you a hint is just go ahead and round that to 2 decimal spaces. So r is about 1.88. So to get the area of the whole circle, it's pi r squared. So I go 1.88 times 1.88 first in my calculator. Then multiply that by 3.14. And that would be the area of the whole thing. And again, we can round that to 2 decimal spaces. And we want to find 2/5 of that, because 2/5 of the circle is shaded. So 2/5 of that. The way I do that in my calculator is I take the area, or about 11.10, right? Because if I round it to hundreds, that's going to bump up. If I look to the right, it bumps up. And then I go 11.10 times 5 equals, then divided by, times 2, then divided by 5. That's how we do 2/5 in a calculator. We take the number, we multiply by the numerator, and then we divide by the denominator. You should get 4.44 centimeters squared. 18, we have a composite area. We got a couple shapes put together. We got to find the area. The rectangle on top is 8 by 4, so 8 times 4 is 32. Because how do you find area of a rectangle? You just go base times height. And then the big rectangle on the bottom, you should do 24 times 5. Then all we do is add those two. You should get 152 square units. For the next one, we have 2 rectangles and a triangle. So if I looked at the rectangle on the side and I go all the way down to the bottom, it's 8 all the way to the bottom. So 8 times 2 is 16. Now if I look at the triangle, the rectangle at the base. Now this part right here I've already used, so we can't use that twice. So if you're doing it the way I'm doing, this is not the only way to do it. This is just one right way to do it. But if you're doing it the way I'm doing it, if you go all the way to the bottom with this one, then you can't count this part right here 2 times. You can't count this part twice. So I took that part off of here, right? That's why I did 9 take away 2 to get 7. So this area down here is 7. So look at your diagram, make sure you understand that. That should be 7, and it's a height of 4. So 7 times 4 is 28. Now the triangle, we get the height from the side, right? Look to the side, you'll see the 4. But this base down here, because we need base and height to get area of a triangle. This base down here, if I look at the sides, I want you to find the sides. Look at the 2 and the 3. If I add those 2, I get 5, but I have to take that away from the whole enchilada. Take it away from 9, and I see that this base of the triangle is 4. So the area of that is 1/2 base times height. Half of 16 is 8. Add those numbers up, you should get 52 feet squared. Same idea for number 20. But this time we have a rectangle, another rectangle, and a triangle. So if I look at the one big rectangle, and we're going to say that's 22 by 25, so notice I'm not using the 18, I'm going all the way to the bottom there. So I'm going like all the way to the bottom at this part right there in the drawing. So I get 550 for that, right? It's just base times height. Next one, if I'm going to get this base, because remember I already used this part right here for this one, right? So that would be 12 by 4, and the way I got 4 is I did 22 minus 18. Look at your diagram to see how I did that. So 4 times 12 is 48, and the triangle is going to be 6, and the way we get that is to get this distance down here at the bottom. Okay, I can add up 25 and 12, look at your diagram and see where I get that, to get 37. Subtract that from all the way across, subtract that from 40, and we see that the base of the triangle is 3. We got the height from this part right here, that's the same as that, that's 4. 1/2, 4 times 3, or 1/2 of 12 is 6. So we got 550 plus 48 plus 6. Add those up in your calculator, you got 604 feet squared. Hope that helped.